In this video, we are going to discuss about signal distortion in fiber optics or optical fibers. So let us see what are those signal distortion. When optical signal pulses travel along the fiber medium, the light intensity or power decreases, that is the attenuation, over a distance, and the width of the pulse broadens, that means it will disperse. So what will happen whenever it travels through a longer distances, and that means optical signal pulses travel along the fiber medium, the light intensity or power that may decreases over a distance, and the width of the pulse broadens. So basically, there are two types of signal distortions in the fibers. So one is the attenuation dispersion, one is the attenuation and the other is the dispersion. Attenuation is the reduction power, that means the reduction of power level or reduction of light intensity. So attenuation limits the optical power which can reach the receiver, limiting the operating span of the system. That means it will decreases the power of the light, intensity of the light. And dispersion, that is the pulse broadening effect. That means we are using a laser source for this purpose, as we are early said in the classes. That means we are using the laser as a source. But whenever this dispersion occurs, that means the broadening of light occurs. When light pulses travel along the fiber, the width of the pulses broaden. So this is called dispersion. And next, attenuation in optical fibers. Let us see what is the attenuation in the optical fibers. Attenuation decreases the light transmittance. That's a fiber. Light has a total internal reflection, inner core with high refractive index and outer cladding with low refractive index. So usually the power of the light at the output end of the fiber is less than the power launched at the input end. So then the signal is said to be attenuated. So for the purpose of complete transmission, complete intensity transmission, complete information transmission, we are using a fibers instead of normal cables. So here also we are facing the problem of attenuation. So the signal attenuation is defined as the ratio of the power of the light coming out at the output end to the input optical power into the fiber. That's the signal attenuation. And that means it was a ratio between the intensity at the input and intensity at the output. So the attenuation coefficient is given by, that is alpha. We are saying the attenuation coefficient as alpha. That's a loss per kilometer, that equals to minus 10 by L log of P output by P input. That will be, the loss will be measured in decibels per kilometer. That is L is the length of the fiber. Okay, so attenuation loss is generally measured in terms of the decibels. Okay, so attenuation is the function of wavelength, fiber material and length of the fiber. The cause for attenuation or waveguide structure, material compositions, material scattering, microbending losses, mode coupling radiation losses. So all these factors combining, and those causes the attenuation losses in the fiber. That may be a structure or material composition or material scattering, whatever we are taking, or bending losses in the fiber. Those are all reasons for the attenuation. So let us see what are those losses in the fiber losses. The basic attenuation mechanisms, so the scattering losses, absorption losses, radiative losses. That is, the scattering losses occurs due to the fiber structural imperfections, and absorption losses due to the fiber material, and the radiative losses due to the bending of the fiber. Okay, now scattering losses. Scattering is a process in which all or some of the optical power is transferred from one mode to another mode, that is from guided mode to radiation mode. So that means the light will scattered inside the fiber. What causes the scattering losses? Let us see. Macroscopic variations in density of the fiber material. So it is, the density means mass per unit volume. Okay, so the density of the fiber material, the microscopic particles variation that causes, and compositional fluctuations, structural inhomogeneities, and structural defects in the fiber. Those are causing the scattering losses. Okay, so the molten glass, when drawn into a very thin fiber under proper tension, causes submicroscopic variation in the density of the glass in the fiber takes place. So we are considering the molten glass, and the dopants added to the glass to modify the refractive index also causes the fluctuations in the refractive index, which leads to inhomogeneities in the fiber. So the microscopic variation of density and inhomogeneities acts as reflecting and refracting facets. Due to this, a portion of light signal passing through the fiber, that means a glass fiber or a plastic fiber, that gets scattered. So this causes the scattering losses in the fibers. So when inhomogeneity size of the fiber is smaller than the wavelength of the light, then that scattering is Rayleigh scattering. When it is greater than 1/10 of wavelength of light, then that scattering is Meyer scattering. Okay. So how to minimize this scattering loss? Whenever we are overcoming this, so then automatically the fiber is good for communication. So how to overcome this means by minimizing compositional fluctuations by using best manufacturing methods and removing imperfections due to the glass manufacturing process, and carefully controlled extrusions and coating of the fiber, increasing the fiber guidance by increasing the relative refractive index difference. So we already know the major role played by the, that was played by the core and cladding. So there is a variation between core and cladding, that has, core has high refractive index and cladding has a low refractive index. Okay, and next let us see what is the absorption loss. Material absorption, that is mainly caused by the materials present inside the fiber optic cables. When light gets absorbed by these materials, this type of loss is created. So whenever we are instanting some light into the fiber, some portion gets absorbed by the materials present in the cable. So this type of losses are known as material absorption. So material absorption is caused by absorption of photons within the fiber. So two types of absorptions are intrinsic absorption and extrinsic absorption. Let us see what is the absorption losses, how it will exist. Intrinsic absorption. Intrinsic absorption in UV region. It is called caused by electronic absorption bands. So here we are already discussed in the lasers, that is the energy levels. Okay. So it occurs when a light particle interacts with the valence electron and excites. So the incident photon here, it is in a ground state. So by observing this, it will go to the second state. Okay, so it occurs when energy band gap of material is less than or equal to photon energy of light traveling along the fiber. So whenever the intrinsic absorption loss occurs, means the band gap of the material is less than or equal to the photon energy of incident, that means the light traveling along the fiber. So it also caused due to the absorption of photons in fiber medium, which transforms heat energy and dissipate outside the fiber medium. So that is also affected by the heat. Okay. And next, intrinsic absorption of IR. This is caused by the vibration frequency of atomic bonds. That is, in silica glass, it is caused by silica oxygen covalent bonds. So covalent bonds being weaker, so they absorbs photon energy, vibrates and dissipates as heat energy. We already know what is ionic bond, covalent bond. Okay. And next, extrinsic absorption. It is mainly due to the presence of impurities such as FeCuCO, that means ferrous, copper, cobalt, okay, like that, all in the silica, within the silica structure of the fiber cable. It is also caused by the presence of hydrogen ions in the silica glass fibers during manufacturing process. So extrinsic means we are adding some dopants to the intrinsic materials. So the extrinsic absorption is also, that is due to the presence of impurities in the fiber. Okay. Next, bending losses. What causes bending losses? Abrupt change in radius of curvature of the fiber causes bending loss. Whenever an optical fiber deviates from a straight line path and undergoes bends or curves on their paths, radiation losses occur, which causes light energy to be radiated from the fiber. So here is a macro bending and micro bending. Two types of bendings is there, macro bending and micro bending. Okay, so the it changes the path due to the bending of fiber. Okay, see, macro bending occurs when a fiber cable turns a corner and macroscopic bends having radius that are large compared with the fiber diameter. So, micro bending is an imperfection in the optical fiber. It is created during manufacturing. So, a large number of small bends present in the fiber causes large attenuation in the signal transmission. So as the number of micro bending increases due to the manufacturing, so then the attenuation in the signal transmission will occur. So micro bending can cause extrinsic attenuation also and a reduction of optical power in the glass. Okay, and let us see how to minimize the macro bending and micro bending losses. Before going to that, micro bending loss refers to small scale bends in the fiber, often from pressure exerted on the fiber itself or lateral stresses along the length of the fiber when it is cabled. So grouping of fibers also it will occur, or external pressure or itself. Mode coupling occurs when fibers suffer small random bends along the fiber axis. So the bending occurs along the axis of the fiber. And next, how to minimize the macro bending losses. Designing fibers with large refractive index differences and operating at shorter wavelengths. And how to minimize the micro bending losses. So decompressible buffer jacket should be used to avoid micro bend. That means decompressible buffer jackets. So buffer jackets is nothing but a protecting layer that should be used to avoid the micro bends. And when external forces are applied to this jacket, the jacket will be deformed, but they will tend to stay relatively straight. Okay, so whenever we are applying a force on this jacket, also the jacket will be deformed, but the that end, that means that tends to stay relatively straight. Okay, and next, see how the input output, that means why the absorption loss, how the absorption loss will be, how the scattering loss will be, and heterogeneous structure scattering losses. Okay, and splicing losses, that means splitting, and macro or micro bending losses whenever the impurities are present in that. Okay, this figure completely shows all types of losses. Okay, and next,